The aim of this video is to introduce the org compiler directive, and after this video you should be able to discuss and use the org compiler directive to structure code and increase readability. Org is another compiler directive which is used when programming the PIC. Org is used to compile program code into specific program memory areas. Its primary use is to place the interrupt service routine code right at the interrupt vector, which is location 4 hex, or to ensure that code is not placed at this location when the interrupts are not used. When looking at the example code, it can be seen how the instruction goto init in line 3 is placed in program location 00, and the instruction return from interrupt is placed in program location 04 hex. This is accomplished by the two org directives on lines 2 and 5 respectively. Please note that these directives do not form part of the final compiled code, as can be seen in the compiled memory example. The org directives are not compiled into the program memory. After opening the PIC Simulator IDE, remember that you need to select the controller that you're going to use. You can do that by clicking on the name of the controller that's there. I'm using the PIC 16F627A. You can select either one of the controllers, preferably the one that you're actually using. I'm going to stick with the 16F627A. Select that, and also make sure that you've set your clock frequency to 4 MHz. Previously I said that you have to have these 4 lines of code in your program, and I didn't really give you an explanation of why. In this video we are going to look at this specific explanation. In order to understand what is happening, you have to understand two things. The first thing that you need to know is that the reset vector of the PIC is at the location 00 hex. What does that mean? Well, it means that when the PIC resets, or when you apply power, the program counter of the PIC will be reset to location 00, and whatever code is at that specific location will be executed. In this case, the code that will be executed is going to be goto initialize. The second thing that you need to remember is the reset vector. The PIC has a single reset vector at location hex04, and when a reset occurs, whatever code is written at location hex04 is going to be executed. The program counter will jump to location hex04, and the code that is there will start to execute. So let's have a look and see what the code looks like when we compile this. So we go to Tools, Assemble and Load, and if we now look at the program memory editor, we can clearly see that the goto command is programmed into location 0, and we have the return from interrupt command, which is placed in program memory location 4. The goto main is placed in location 5, which is obviously then the next command after return from interrupt. Remember that labels are not placed in the program memory. So now that you can see what the purpose of this is, you might ask, but this is not really that big of an issue. The problem is that if you forget to disable the global interrupt enables, you might have a situation where an interrupt occurs and the program counter jumps to location 4, and the code at location 4 will start to execute. If you have a large program, it might mean that the interrupt vector jumps into the middle of a subroutine, and then you might have some unexplained bugs or some unexplained behavior from your program. So it is extremely important that these 2 lines of code is included, even though you might not be using interrupts. Just for fun, let's add another org statement in here and see what happens. I'm going to org x10, so at location 10 hex, I want to add the following code. Let's just set up the port. So this is port B, no, that's wrong. Let's set file status, RP0, going to bank 1. Then I want all of port B to be output, so that's clear file port B. And then I want to move back, but clear file status, RP0, so I'm moving back to bank 1, back to bank 0. And in the main routine, let's just toggle the output, so bit set file port B, 0, so I want to just turn that on, and bit clear file port B, 0. So these 2 lines, that line sets port B0 and this line clears port B0, but that's not important. What I want to show you is what happens because I've put in the org x10 command. So tools, assemble and load. And look at how the program now changes. The program memory rather now changes. We still have at location 00, we've got go to 10. Then at location 4, we have return from interrupt. And if you now scroll all the way down, you'll see that your program only starts at location 10 hex. That is exactly what we want from this org command or org compiler directive that we see there. We've moved the program memory counter to location 10, and the commands or the instructions that follow this org will be placed starting at location 10. And you'll see there we have bit set file, we have the clear file, bit clear, bit set, and we have the go to back to the main routine. After you've done this, you can just close PIC Sim IDE if you want to, or you can leave it open and do a few experiments on your own. In this video, we've looked at the org compiler directive, and we've specifically looked at how the org directive is used to place code at specific locations in the program memory.